Ooh, look at this one. So we've mastered solving our two variable systems of equations. So let's take a look at three variable systems of equations. How cool is that? When you have a three variable system of equation, you're doing the same concept. So with your two variable systems, you start off with two variables. You break it down to just have one variable that you solve for at a time. Same concept applies here. With these three variable systems of equations, the first step is to get two new equations. And with these two new equations with only two variables. That's the goal. If I get two new equations with only two variables, then that is how I can break it down and we can work from there. Like we have for the problems leading up to this one. So you break it to the two equations, then you break it down to the one variable, and then you go back up the ladder. So in order to get two new equations with only two variables, you have to pick a variable to eliminate. So you look at your choices. As I'm looking at my choices, I look at my x's, my y's, and my z's. What I can see right now is these two z's already are something that can cancel. So my goal with two new equations is I'm going to put two equations together and then two other equations together in order to get two new ones. My choice for this one's going to be the z's because I already have it set up to where it's going to be easy to work with. So if I put these two equations together, that's going to be my first new equation. Then I'm going to put the top one and the second one together, and that's going to be my second new equation. And the reason why I chose those is because 6 is positive and z is negative. The top one and the bottom one, they're both positive, so I might as well go with one that's already positive and negative because we're going to use the process of elimination in order to do that. So for this new number one equation, we're going to put these bottom two together. So I have 2x plus y minus z is equal to 2. It's a z. And then I have x plus y plus z is equal to 2. Whenever I combine these, the z's cancel, and it's the same as the addition method, the elimination deal. So I eliminate those and I add the rest of them together. So 3x plus 2y is now equal to 4. There is new equation number one with only two variables. The key to this is the two variables that you have left over have to be the same variables. So whenever I put the top and the middle equations together to get new equation number two, I'm going to have to eliminate the z again. It doesn't do any good to break down two equations if you're not going to come up with the same variables because you're no better off at that point. So the goal is to start with 3, break it down to 2. Once you have the 2, break it down to 1 variable, and then you go back. Have your 1 variable, plug it into your 2, plug it into 3. So that's kind of the goal when we get this. For this equation, I'm going to multiply the bottom one by 6 so that I can get it to where I can eliminate my z's because I still want to eliminate those z's. So we have 12x plus 6y minus 6z is now equal to 12. Then I bring this one down. 3x plus 9y plus a 6z is equal to 3. So the z's cancel. I now have a 15x plus 15y equals 15. How about that? That's funny. Cool. Now we put these two together. So I have a 15x plus 15y is equal to 15, and 3x plus 2y is equal to 4. Now, of these two choices between x and y, which one do we want to eliminate? Yeah, that's what I would do. Totally go with those x's. Because the x's, the only thing I have to do is multiply the bottom one in order to get it to cancel. This 15 and 2, that would be a mess. We don't want to mess with a mess. So I'm going to multiply the bottom by a negative 5 because we want it to be the opposite. So that gives me a negative 15x minus 10y is equal to a negative 20. And then just rewrite this one. So 15x plus a 15y is equal to 15. Now I get a positive 5y is equal to a negative 5. So y is now equal to a negative 1. There's our first variable. Da-dun-da-dun, da-da-da-da. Then I'm going to take this variable and plug it back into one of the two new equations. Now my choice is going to be the red one, because if I plug it back into the red one, my numbers are smaller. So I have 3x plus 2 times negative 1 equals 4. So now I end up with 3x minus 2 equals 4. Add 2 to both sides. So 3x is now equal to 6. Divide by 3, and x is equal to 2. Now I have an x, I have a y. The only thing left is to get a z. So we can do that by plugging it in either to the top, the middle, or the bottom. My choice probably would be the bottom one, just because there's fewer numbers and it makes our lives easier. So x plus y plus z equals 2. So plug in everything we know. We know that x is 2, y is a negative 1, that's a z, plus z. So 2 minus 1 is 1, plus z is equal to 2. Subtract 1 from both sides, and z is equal to 1. Da-da-da-da-da-da! Awesome! When you write your final answer, you're going to write your final answer as a coordinate point. So before, we've always just had x, y points. Now that we have a z involved, you have to put that in there. So we have an x, y, z point. So it's 2, negative 1, and 1 as your final answer. Woo! Now these take a little bit of time, and there are several places that it could go wrong. Just take your time, slow down. You've only got a couple in your homework, and you'll have one on your test. But just take your time, look at their little things, and then you can go from there. Cool. Let's do some more. Awesome. So we have done it all. We've done substitution method, elimination/addition method, and then there's 3 variable systems. With your substitution method, you want to look for a variable by itself. That's the best way to do the substitution method. Your elimination or addition method, or x and y are on the same side. So once you know that x and y are on the same side, then you want to get the same coefficient that is opposite in sign. So the same number, except one's positive and one's negative. That's the goal there. Awesome. And then lastly, the 3 variable system, you want to break it down to 2 new equations with the same 2 variables. So you want 2 new equations with the same 2 variables. Then once you solve for those variables, just like you do with the substitution elimination method, so basically the elimination method's where you're going with there. So solve for those variables. Once you have those 2 variables, then plug in to get the third. Then plug those in to an original equation to get the third variable. Awesome. All right, let's solve some linear systems.